Okay, here we go. Here's where we're picking up right here on our notes. Let's lock it in. 3, 2, 1. All right. So we were talking about our prisms the other day, right? With our rectangular prisms or our square prisms, and then our any other shaped prisms, which for you guys are going to be basically triangles and trapezoids, because we need trig to get into our hexagons and other shaped prisms, and so we can look at those a little later on in the year. But let's also talk a bit about our circular prisms, aka our cylinders, right? So these are our two base circular prisms. So highlight the bases for this. We'll just do that on the example right here. So on this example right here, I want you to highlight the bases. Go ahead and do that now. Good. So here are your two bases, right, that you were highlighting. Okay. Now again, if you recall, we were looking for the lateral area and then the area of the bases, right? Now we're talking about circles here. So what I'd like you to do right now is I want you to tell your neighbor, because I'm going to ask one of you, what is the formula for the area of a circle? Tell your neighbor what the formula is for the area of a circle. Go ahead and do that now. Area of a circle. Aiden, what do you got? What'd you tell your neighbor?
I asked him.
Oh, you asked him. Brody, what'd you tell him?
Pi r squared.
Good, yeah. So it's pi times our radius squared, right? Okay, let's talk about the circumference of a circle. Tell your neighbor what a circumference, what is the circumference of a circle? Tell your neighbor what that is. I'm going to ask one of you to tell me that in a second. You got 10 seconds. In 3, 2, 1. All right, Vance, what do you got? Circumference of a circle. Yeah, so it's 2 times pi times radius, right? Okay, so now we start talking about the surface area of a cylinder. Wait, what's going on here? Is this a circumference, 2 pi r? Is this an area, pi r squared? What is it? It's both? So this is, so you're saying this is area? This is circumference. It can't be both. One is the belt that goes around the outside. The other is how much space is in the middle. Can't be both. It's what? So this is area, not circumference?
Yeah.
How about we take a vote? Let's take a vote just for the fun of it. Okay. Is this about area or is this about circumference? Let's go. Area 1, circumference 2. What do you think? Area 1, circumference 2. Is this about area 1 or circumference 2? Which one is this about? Area 1 or circumference 2? This is about area 1. Okay.
I saw the square.
That's good, actually. That's what you should be looking for. All right, now listen. Shh. All right, watch. Watch. This is why this formula gets a little confusing. Okay? Because when you're looking at this right here, it looks like a circumference formula, but really what this is 2 area formulas. That's what the 2 is. The 2 is a quantity. It's 2 times the area of one of the bases because there are 2 bases. Okay, good. Good, good. Now, what's going on here then? Is that circumference or is that area? Or is that something else? Is this circumference or is this area? Area? This is area. Let's take another vote. Let's go again. Here we go. Does this have to do with area 1 or circumference 2? Area 1 or circumference 2? Is this area or is this circumference? Which one? Area or circumference? The answer is, it's both. What? I know, I didn't give you that option. I know. But, watch this. It is the formula for the lateral area, like, if you unfolded, a wrapping on a big old like can of juice or something, right? You would get this, right? Okay. This is the lateral area, right? But like, let's think about something for a second. This is height. What do we usually call this? Base. And length and width is old school. Remember I said that, right? Base and height meet at 90 degrees, right? So shouldn't the area of this be B times H? Okay, so if this is area, why is it not B times H? What? Oh, there's a 90-degree angle there for sure. Look at that. There's absolutely a 90-degree angle right there.
On the cylinder.
Well, but I'm talking about this area right here, right? Because I unfolded it.
You wouldn't use that.
Well, I wouldn't? Why not? It's a square?
Bro, what?
It's not a square anymore now, is it? Huh? I just wrapped it around the can, didn't I? But what is this distance right here? What do we call that distance? That's the circumference. And what is the circumference of a circle? No. What is the formula for the circumference of a circle? 2 pi r times the height. See that? This is 2 pi r because that's the circumference of our circle, like that, times the height. Okay? So, when we bend it in a circle, that's what we're talking about. This is our base of our label. Got it? So here are our two areas, and then this is our wrapping around the can. Everybody got it okay? Okay. All right, then let's do some work together. Okay. Let's highlight our bases on number 9. Let's highlight our bases on number 9. Ready, go. This is highlighted. You should have done that right there, yeah? 2 circular bases. All right, let's start with our lateral area. Okay, so our lateral area, let's focus. Our lateral area is going to be 2 times our pi times our something, right? Okay, why don't you fill in the numbers that go there? We're looking for the lateral area. Your question, F? Okay. Okay. So you'll want to check Google Classroom for the homework. There's not an additional paper. All right, ready?
Yes.
Okay, you should have put in
11 and 1.
All right. Now, a lot of you miss this on the test. Okay? So let's not miss it here. I want the exact answer for the lateral area. I want the exact answer. Yeah, that's what I said at the beginning of the test.
What is the exact answer?
It's a great question. That's what I want.
That's what pi is. I remember. That's why I got it.
Okay, I'll phrase it this way. I do not want the approximation. I want the exact answer. I don't want an approximate answer. Okay, see if you can figure it out. Two, one. Fisher, what's the exact answer? 572 pi. Very good. Now, we're going to leave the units off right now because we're not coming up with our final answer. Yes, ma'am. Yeah, that's fine. Find a place wherever you want to go. I don't care. Okay, so this is the exact answer. I don't want the approximation, right? Okay, now, let's find the area of one of the bases. The area of one of the bases. So then this is going to be this, right? Okay, why don't you find that? Go. Exact answer. You should have come up with 121 pi. Very good. All right. Now that we have the parts that we need, we can begin assembling our surface area which is 2 of our areas of our bases plus our lateral area, right? So what are 2 of our base areas combined together? Right? Plus our lateral area. 2 times 121. Because it's 2 bases. So this right here is the area of one of these, pi r squared. But there's 2 of those. So then we just multiply the 2 times the 121. We get 242. Well, that's because you got to add. Now you add these up. For the whole surface area is 814 pi what? Okay, I saw this mistake a lot on the test. Watch up here. Watch up here. That's wrong. Pi is not squared. It's not the pi that's squared. It's the yards that are squared. A lot of people left units off on that one too on the test. So, all right. Surface area. Find your lateral area. Find one of your bases. Jackson, can you put that down, please? Okay. And then put it together to find your surface area. Good?
Yes.
All right. So then I'm going to have you do number 10, and I'll give you some checkpoints along the way. All right? So we'll give you some checkpoints along the way. So go ahead and give number 10 a start by highlighting your bases, jotting down some things that might be important for you, and then just like we wrote our workout for number 9, you're going to start writing your workout for number 10. Go ahead. Check and see that you're moving in the right direction here. Okay, keep going. Here's another checkpoint for you. Make sure you're heading in the right direction. And then finish it up. Just a checkpoint, it's not the answer. Up with 247 and a half pi meters squared. How many people got it right? Let me see around the room. Who's got that one right? Let me see around the room. Who got it right? Let me see around the room. Who got it right? All right. Okay. All right. Shh. Let's bring it down. All right. Here we go. All right. Now, our goal for today was to bring in cylinders so that we can expand our repertoire on prisms. Because now we can do trapezoid, triangular, rectangular, square, and circular prisms. All right, now, 11 and 12. Hang on. Shh. Listen. Listen. Jace. Okay. I'm not going to have you do 11 and 12 right now in class. They're a little bit more challenging questions, okay? However, they might be the type of questions that I ask, like, for extra credit. So, what I'm going to do is I'm going to work these out for you on the end of the video of the class. I'd recommend giving them a try just to challenge yourself and then check your answers and see how you did. You don't have to. It's not required, but I would recommend it if you're wanting to kind of, be on that edge of working with those more difficult questions. Now, one thing I will tell you, write this down in case you do want to try these. For number 12, you are going to need to use the pi approximation. So I want you to round to the hundredths as you're working through this problem. Now, you're either going to use your pi button on your calculator, or if you don't have a pi button, which most of you should, you're going to use 3.14159. Okay? That'll get you close. That'll get you pretty close if you don't have a pi button. Okay? So if you want to try those, you can go to the end of the video by the little answer check screen, and then you can see how you did, and I'll let you work on those on your time for a little extra challenge. Okay? Good? All right. Any questions before we move on? Ready to move on? Outstanding. Okay, so here are 11 and 12, and with each of these, right, the question is actually starting with the fact that we know the surface area, right? We know the surface area there, we know the surface area here. We've already got that information, and so now we're working with finding another piece of missing information. So in this case, for number 11, right, we're talking about our length. We're looking for the length of the box, right? So this length right here. And so you just fill in the information. You start with your formula right here. We've got our surface area goes out here, and then it's going to be our 2 times length, right? So that's going to be one of our measurements, this measurement times here, right? And then we're going to have our length times 12. That's going to be one of our measurements here. And then we're going to have our 2 times 12, right? And we're going to have that measurement. And so then we just calculate our numbers all the way across. So this is a variable term, constant term, combine like terms, and divide off, and we come up with 8 inches in length across the bottom. Now that one should have been pretty straightforward, but that leads you into 12. So that's what we're going to focus on now. Is now we're looking for the height of the can, but again, we're given the surface area. Now I mentioned that this one, you are going to need to use your pi button. You're going to need to round to the hundredths as we go through this problem, but it's the same concept up above, right? We start with our surface area right here, and then we do our surface area, which is a 2 of our base of the solid areas, right? So our pi r squareds, right? And of course the diameter is 3 inches, so we're cutting that in half. And then our lateral area, which is our 2 pi r h here. So then we can get this into our exact pi terms, but then we have to begin to do our rounding, right? And so I do 4.5 times pi, and I get rounded 14.14. And then I do 3 times pi, and I get 9.42. And then I still got my h variable in there for my height. And then I subtract off my 14.14 from this side. That's going to get me my 37.7 here. And then finally, I divide off my 9.42, divide off my 9.42. And that gets me my height of 4.002. I think it goes like 1, 2, 3, 1, whatever, blah, blah, blah. But we're rounding to our hundredths here, right? And so in this case, if we were rounding to our hundredths, it would just be 4.0 or 4 inches on our height. Okay, so that's how you do those 2 questions. Again, a little bit more challenging questions, but I think you will see some of those show up in some of the practice problems, and so that would be some good information to have for you. All right, there you go.